Hello, Magenta. I refactored code where AI got stuck. I was almost driven crazy by this bug while vibe coding with Claude. At first glance, it looks like a little compile time error in Go, but actually it reveals a deeper design problem that in how the handler is structured. The error says cannot use mock SB as Supabase client, which usually makes people think, oh, I just passed the wrong type. But the real problem is not the mock, it's a function signature. My handler is tightly coupled to a concrete implementation, so no mock can ever satisfy it. So what does my handler look like? This handler works, but it's already broken in terms of design. The handler depends on a Supabase client, not an interface, not a behavior, but a concrete implementation. And it makes the mock side rely on the concrete implementation as well, which is impossible. And there is a very common mistake that how developers would come up with to deal with it. Like when the compiler complains, the easiest way is to any everywhere. At first glance, oh, it's flexible. We accept any, so we can inject anything. But what we actually did is postpone the fear. So no one can guarantee what type claims in runtime. We just move the fear from the compiler time to the runtime, and runtime fears are always sports. Here is another common mistake that people would make. Like, okay, this is a unit test. We unit test, integration test. I cannot see any differentiation from there. So just mix them. Like we just regard this unit test as integration test. In real projects, having a few E2E or integration tests is totally fine, but they cannot replace unit tests, and we shouldn't mix them. Look at what this test needs: real Supabase credentials, CD data, real JWT, and it even hits the network. That means it's flaky by design. Read limits, latency, environment drift, anything can break it. And once you mix them, you will run into classic plane like, okay, say I read, but I don't know why. It works on my machine, but fails in CI. Why? So we should keep in mind that don't mix the unit test with the integration test. And a good unit test should follow one simple principle: no network, no third party, the dependencies, and no other third party thing. Okay. And determines coverage for edge cases. And what's the solution? Here is the correct approach. At first glance, this diagram looks a little bit abstract, like so many boxes, but it's totally okay. You don't need to fully understand it. The key idea is simple. The HTTP handler does not depend on Supabase directly. It depends on interface. That means it's a user store. In production, we have a Supabase user store that implements this interface and a unit test and a delegate to the real Supabase client. And in the unit test, we swapped it with a mock user store. No network, no credentials, and no external services. That's it. Same handler and same behavior, just different implementations, and depends on where you run it. If this does not fully click yet, that's completely fine. Architecture is best understood through code, not diagrams. So next, let's walk through step by step and reflect it and see what we actually changed, okay, line by line. In this code, we define the interface user store. We define it with a single responsibility, giving a user ID and return a user. How the user is fetched, database, API, or more, is not the handler's concern. And second, after we define the interface, is by implementing it. And implement the interface, we have two implementations of this interface. The first, on the production side, we implemented with an adapter. This adapter talks to the real Supabase client and performs actual database operations. And on the unit test side, we provide a mock user store. It implements the same interface, but instead of hitting the database, it returns the mock data. So get user by ID behaves the same from the handler's perspective, giving a user ID, return user, and just without any external dependency. So our next step is we have already defined the interface, implemented it, we have to give some changes to the handler, right? So let the handler depend on the user store interface instead of a concrete implementation. Previously, the handler depends directly on Supabase client. It tightly couples the handler to an external service and makes unit tests very difficult. Now we have introduced the user store interface. The handler no longer needs to know how the data is fetched. It only cares about what behavior is provided. So we update the handler to depend on the user store interface we defined instead of previously the concrete Supabase client. Okay, all this work. A natural question is, where do we pass the interface implementation into the handler? The answer is in the router. Previously, the router constructed a concrete Supabase client, as we said before, and pass it directly into the handler. Now we explicitly construct an adapter that implements the user store interface. This adapter was a real Supabase client, and it translates interface calls into actual database operations. And finally, the router passes this adapter, not a raw cloud, we wrap it into the handler. So the router becomes the composition root, the only place where concrete implementation are wired together. That's all. We have done everything. Let's give a recap. The HTTP handler depends only on the user store interface. In production, this interface is implemented by an adapter that delegates to the real Supabase client, and the unit has the same interface is implemented by a mock, allowing the handler to be tested without Supabase or any network access. This separation keeps the handler focused on behavior, improves the test reliability, and avoids mixing unit tests with integration concerns. I'm currently building LibPulse, a telemetry platform for devtools, and you can take a look at these changes in this PR. Feedback is very welcome. And if you find it useful, a star or a vote would be appreciated. Thank you, Magenta. I refactored the code where AI got stuck. See you next time.